Object relational mapping is a big topic for us. So I'm going to introduce it here in these slides, and then we're going to have another bunch of slides to talk about a very specific object relational mapping tool that we're going to use. And then we're going to also have a video that kind of breaks it down and does it by example. Now, I do highly recommend that you do these in order because they will make a lot more sense if you do. That said, I realize that some of you have varying levels of knowledge maybe coming into this, where you might have used ORMs or object relational mapping tools in the past, and I understand that, but also remember if you skip around that you'll want to come back here for sure before the test and make sure that you know the content so that the finals questions will make sense. But what an object relational mapping tool is another way for us to connect our object-oriented programming languages to our relational database models. Now, what we've seen up until this point was doing embedded, which we really don't use all that much. We talked about that last week in the present day, but it is still an option. We talked about stored procedures, right, where we actually put the business logic into the database itself, and then we call that function from our code. That was another option. We talked about kind of the pros and cons of that, right, that it offloads some of the load from the application to the database, so that might be a good thing or a bad thing, right, because now your database is taking on some of that application logic load as well as its own load of calling for data and retrieving it. And the last one we talked about was CLI, which is by far the most prevalent today. And that's the idea that we most likely are using some kind of connection library like JDBC to connect to a database and then essentially to pass queries to it. So that library knows how to connect, it knows how to speak the language of the database. You use it to connect, and then you create queries that are either, they could be select, update, delete, insert, the whole nine, and send those through. We also talked about how you should be using prepared statements to avoid SQL injection and those kinds of things. What object relational mapping is now is a way to add another layer of abstraction, essentially, in between our database and our application, that instead of writing those queries manually, it's going to take care of that for us. And beyond that, it's actually going to take a look at your actual data model. And a lot of object relational mapping tools actually create a database from your data model. So for example, if you have a user table in your data model, that user table might be transposed into a relational database table called user, and whatever properties or attributes you have in your object, you would also then get as fields in your database table. And every time you create a instance of a user, you're creating a tuple in that user table, right? It's a way to kind of more closely join together the worlds of your object-oriented world and your relational world. And we'll see in a few moments there's still some big discrepancies there. And we've talked about those a little bit in the past, and we're going to dive even deeper into it now. But for example, if you have a many-to-many relationship, that's an interesting kind of problem to solve here. How are you going to do that? Even a one-to-many, right? In the object world, we would probably have, like, if a user has many addresses, you would probably just have a list of addresses as an attribute of the user. So how do I transpose that now, right, to a table? If I take that user object and I try to have an ORM tool automatically create a table out of it, it's going to look at that and it's going to say, oh, okay, I created first name as an attribute. That's simple, primitive of a string, last name, etc. And then it's going to get to this list of addresses, and it's going to want to create another table inside a table, which it obviously can't do. So there'd have to be a new table for the addresses, and then it would have to create a dependency there for having the foreign key. So there's some things that just don't map completely cleanly. And sometimes you want the structure of your data to be different from the structure of your object. Sometimes there's just not a one-to-one correlation with how these two things work. So all of these details can lead to situations where it takes a lot of time and effort to figure out this mapping. And an object relational mapping tool endeavors to do it for us. It translates between our objects and that relational model in hopefully, best scenarios, best case kind of ways that, tried and true methods that have been time tested and have worked, right? And that isn't always the case, and there's always going to be some kind of issues there where you need something specific, and the object relational mapping tool isn't going to necessarily pick the right way to do it right out of the box. Usually these things are pretty configurable, but knowing how to configure them, to be honest, takes a lot of doing. So we'll get to it later, but there's even a debate on, especially depending on the size of your project, is an object relational mapping layer even a smart move for you and your project? The answer might surprise you. The answer isn't always yes, right? The answer might sometimes be no. So this is pretty much where we're at. As with everything in software engineering, there's no one absolute right answer. But what I want you to know for right now is that what we're building here is a software layer. Typically, it's going to be a library or a framework of some sort that we're going to use on our application. Now, the cool part is, in addition to these cool features it does, like creating the database, managing the data going into the database and all that, it can usually connect, to multiple databases. So it might connect to Oracle and MySQL and Postgres and Microsoft SQL Server. Might even connect to DB2. This is an abstraction. So part of the power of abstraction, right, is that you can use that abstraction to do exactly that. Set up an interface, define that interface, and once you have an interface, we can now code that interface to talk to multiple database systems, right? And that, whatever differences there are between them, are completely encapsulated inside that ORM, and we don't have to worry about them. This is hugely powerful because let's say you're paying Oracle, $100,000 a year or more to use their database, and one day, there's a new CFO in town, and the new CFO says, I don't feel I need Oracle for whatever reason. They don't feel that it's extra security and other features are worth it. So they want you to get it out of there. They want a free solution. So, they tell you to use Postgres or something. Well, if your software has an object relational mapping layer and it supports both those database softwares, then switching it out is a relatively simple affair. I mean, it's going to require testing, but on the whole of it, aside from weird use case scenarios where you might have set something up in a very specific way, or stored procedures or other things that were incorporated in the Oracle database that you had to move across, when it comes to the applications connection to that database, it should be just straightforward. It's just changing the config and pointing it to the new database. So that is enormously powerful, right? And that's another thing that an object relational mapping software gives you. It gives you this freedom of another interface that we can use to connect. And it also, acts as a buffer where you can put cache a lot of times. It can manage caching of data. And there's actually a whole lot else of benefits that it can give you. So there's a lot going on there. Some really common ones that you might have seen out in the world is like SQLAlchemy, or I always say this one wrong, it's Django, or I believe for Python. And Java, the most widely used one and probably the most hated ORM in the world is Hibernate. It's a little bit of a hindrance, I think personally, to set up. It's a pretty big beast. There's another one here that's a little guy that we're going to be using, mostly because it's so simple. It makes it a lot easier for me to introduce this, and it also happens to be a tool that I created. So we're going to talk more about that later. It's going to have its own video. That's 40F-lib. The 40F stands for fourth dimensional form, and we'll talk about what that means later. So it's kind of a play on third normal form. It's fourth dimensional form. We'll get there. PHP uses ones called Doctrine and Propel. These are all just ones that you may or may not have encountered software in your career where it was using ORM. So if you recognize these names and you've worked with it, then you may have already worked with ORMs at some level. They're very, very common. They are not as all-encompassing. It is not a given that every software has to use them, but they are, in fact, very common. So the way this works is we left off with the CLI, right? And we said with the CLI, we're going to connect, using that library. And then once we connect, we're going to then create a statement, right? So that's what we're looking at here. And in this case, we're doing the correct thing, and we're creating a prepared statement, which means that we're going to protect ourselves against SQL injection. This prepared statement now gets a string passed to it, which is the SQL string itself. I don't have it here, but let's say, I guess it's updating an author, right? So the SQL here is probably something to the nature of, update authors, set author value, and then the value will end up being a question mark because we're passing the author in here. And then we're going to pass that in a SQL. We set the string for the thing that we want to change, which is the author, because that's the prepared statement piece. And then we run execute update, because this particular statement is an update statement. Now, what we've done here is, obviously manually write SQL, right? Now, this is not inherently, this is a very different thing. It's a very different style. It's a very different way of thinking than how we deal in object-oriented programming. So wouldn't it be nice if we could say, do this in an object-oriented style, right? So what this is now is a layer that will allow us to do that, but it's important to note that it works with CLI. Like, we're not completely removing CLI, we're just putting a layer on top of it. So it's essentially creating those queries and sending them to the CLI. It might be abstracted away from you, like your framework for object relational mapping or your library might automatically already have the CLI incorporated within it. But for example, if you're using Java, you might still need to have a JDBC connection, right, available to you, something like that. Most likely the ORM is going to have that as its dependency, and it's going to call on it as it needs to. But it's just something to keep in mind, that the CLI concept is not getting necessarily replaced here. We're just adding another layer in between that gives us an option on how we want to represent our requests to the database. We want to do them in a more object-oriented programming manner and less in a database-driven manner. So let's take a comparison now of another one here. This is another CLI statement. This one's specifically a C# program that I grabbed. I think this one came out of Wikipedia. And we're creating a string here for SQL select, and a select ID, first name, last name, phone, birth date, sex, and age from persons where ID equals 10. So obviously we're going to return one person, assuming that ID is the key here, with the ID 10. And then we execute that SQL statement and we put it into a result set. And if we want to output just the first name, what we're doing with the result index 0 is we're saying give us the first row, which is a safe assumption, assuming that ID here is obviously a key. And then it's basically a two-dimensional array. And the second dimension here is the attribute that we want, in this case first name. So I'm putting the first name of the first return tuple into this string name. Now, the same thing can be accomplished with an object relational mapping tool, and it might look something like this, where you have a person P, and you have this repository object, which, by the way, is the instance in this case of the object relational mapping tool, and you're asking that repository to get a person, and you're giving it the ID you want. And under the covers, this object relational mapping tool is effectively creating that same SQL string that you see above, but you don't have to kind of do that. It's abstracted away from you. You just need to know how to interface with this object relational mapping tool as a library and what to send it, which is pretty straightforward. That's the ID that we would have put in the query to begin with. And then once you have this person now as an object, you can get their first name. Now, this is effectively doing the same exact thing. Both of these things actually return the entire object, right? That result set in the first one did contain the entire object. It's only because we asked for the first name on the third line of that first example that we got that single attribute. And we're doing the same thing here. We're getting back a single object in the second example and then using get first name to get that object's name. This example, by the way, is not 40flib. It's another ORM in C#. It's just intended to be generic, and it's intended to show the kind of main difference. And this goes across no matter what object relational mapping tool you're using. The syntax will obviously vary and be maybe more specific to the language that you're working in, but the idea is the same. Past this now, we're going to probably use examples from 40flib. Most certainly when we get to the next videos, but I just want to point out that if you're like working on the project and reviewing these slides to find examples, that was not a good one to use. But it is a very good one to convey the overall concept. So, as I mentioned before, object relational mapping tools can actually create databases, but they can also be connected to existing databases. It depends on the tool, it depends on how it's intended to be used. They all vary a bit here, but you might come into wanting to create a layer like this based on a database that you already have. So, you just want to connect it and kind of match it up to a data model that you're going to create, or many of them. And this is very commonly used, especially in web application design and let's say medium scale application development. You can create the database on the fly right from your data model. So if this is a new application, or like I said before, something that doesn't have this pre-existing data store that you're intending to use, it's definitely a consideration to create your database right from your database model using the object relational mapping tool. So you're going to see that happen when we do our own object relational mapping tool, 40flib. It's going to do that, and your project is also going to do that. You're going to give it a data model of all your classes, and it's going to then create the database and manage it for you. So we're going to get more into what 40flib is now in a moment, but this is just a quick overview. It's an open source object relational mapping tool that I created, I'm thinking 4 or 5 years ago. I started it at least. It's intended to be lightweight, and it actually will make a great pedagogical tool for us. Number one, because I am a little bit rusty, I have to admit. I use it a lot now, but I haven't been updating it. You'll see that the Git hasn't been changed much. It honestly works pretty solid, and it's one of those projects that you got it up to a certain point where it works. I actually do utilize it for most of my new projects that I spin up. It's my ORM of choice because I know it, I know how to use it. It's lightweight, it's simple, and I love it for those reasons. And it also gives history, which I'm going to get more into when we talk about that later. But the big added feature of this is being lightweight, because things like Hibernate, in my opinion, suck. And the other big one is that it has everything you put into it is historically managed. And there's a great little service layer that it gives you for accessing that, and we'll talk about that more. But the GitHub link is here. Please check it out. You will be using it quite a bit in the future. So going forward, I'm going to be using this tool for all of our examples and everything like that, and for the demos for the project. So I kind of went through this in the last slide, so I'm going to fast forward, but this is the two things I just mentioned on the last slide. I just got ahead of myself. 40FLib supports currently 3 databases. Now, this is actually an optional project, so if any of you are interested in this, let me know. If you are interested in helping it support more, and I'll get into the details on that in a moment. But right now it works with HyperSQL, which used to be called Hypersonic, and it's actually mostly an in-memory database, although it can be written to disk as flat files. It's usually used for developers. This is very, very popular database when you are working on a enterprise Java app and you're working in development mode and you're testing code mostly, and the data isn't necessarily important, but you need it to be there because you need to support the application. This is a really good option. It's also a way that vendors who want people to be able to try their software out nice and easy and quick, they'll ship it to be set up to work with a HyperSQL database right out of the box. So that's when you download some large software that is normally database driven. It'll download and install and use HyperSQL with a mock database of demo data. And the person doesn't have to install MySQL, Postgres, Oracle, Microsoft SQL Server, any of those. It doesn't know how to set them up, to connect them, all those good things. You can kind of ignore that part and just get to the good stuff, which is trying out the application. So those are really common use cases for HyperSQL. I think it can actually be used as a database. I don't know of many people who actually do that for anything important, but it could be. Postgres is another one that 40FLib currently supports. I do actually run it in production on Postgres for one of the apps I made for Android and iOS. It's like a game. I think that's the only production thing that it runs on Postgres, but it should work pretty well. I don't anticipate it would be a problem. And I used to, when I had a big software that I was working on for a previous life of mine, I used to build that regularly in both MySQL and Postgres just to make sure, and I don't remember it ever failing. So I'm pretty sure Postgres works as advertised, but I will admit that it is less used. The one that was used the most was MySQL. I don't know if this would work for Maria because I haven't tried it. Again, some years have passed since I made this, and Maria wasn't quite as popular back then. But Maria is obviously a fork of MySQL, so I don't imagine it would take much to get it to work, but it probably has a few things that would need to be tweaked. But if you are someone who has worked with object relational mapping tools in the past and you feel pretty comfortable with the overall concepts and how the data model gets created into a relational database, how the records are updated, all of that piece, and you're looking for kind of a bigger challenge, check out option 2 on the project, because essentially option 2 is if you want to create another database supported here for 40FLib, that would be your other option, right? So not something that in any way anyone has to do. It's only there in case you feel you kind of want to take on a new challenge. The cool part here is if you've never worked with reflection in Java, or maybe you've touched on it but would love to learn more, it's a very advanced programming technique that was used heavily in making this work. And I guarantee you, if you embarked on this journey, you would understand reflection pretty well at the end of it, which is actually pretty powerful. So it's one of those advanced kind of language features that not a whole lot of engineers use frequently and understand well. So if you're looking for a nice challenge, this could be it. The other thing I'd say is it's not extreme, because you have 3 examples here that have been created and everything's written to an interface. So it's pretty much following along with what's already been done and modifying it for whatever changes there are for the new database. That's essentially what it is. It's still a good amount of work, but I don't think it's as insane as it might sound. If you've ever, if you're comfortable working with libraries and you understand how ORMs work, then I think this would be right up your alley. So let me know if you're interested in that.